Hi friends, today let's talk about design data intensive applications, Chapter 2. We'll first start with the data models, document model versus relational model, and then we'll talk about query languages, imperative languages versus declarative languages. And lastly, we'll talk about graph-like data models, which is a relatively separate topic. Let's get started. Let's start talking about relational model versus document model. Relational model stores everything in a table format. So you can think about it's like a bunch of tuples. You have, for example, key, and you have column 1, you have column 2, column 3. Whereas document model, it stores everything not in a row, but independent document. For example, here it could be like key, column 1, key, field 1, field 2, field 3. And it's a separate document. What's the difference between these two data models? Why are there two different data models at all? First of all, it's a schema difference. Relational model has what is called static typing. It's also called schema on write, whereas document model has dynamic typing. So it's also called schema on read. What does this mean? Document model actually you can see here. Since each document is independent, you can add a field or reserve a new field relatively easy. So we see document model schema is more expressive and easy to change. Whereas relational model, when you have the table, you already have to define a schema. So changing schema for relational model requires more work. If your data schema requires constant changing, then document model is your best choice. Another difference, as we can see here, is that document model, it loads everything in one document. Whereas if your data requires drawings and are relatively interconnected, then you want relational model. So many to many and many to one. So drawings are more expensive for document model compared to relational model. An example like linking profile. In order to load your profile page, you can either store it in a document model or store it in a relational model. So when you store it in a relational model, you have to do the joins yourself. So your application code will be more cumbersome and has to handle the joins if you use relational model. In contrast, if you use document model, your application code is relatively easy. So you can just load the document itself without doing all the joins. It also brings an advantage here with document model is that the data locality. You can store all the data of this user in one place. So let's summarize here. Relational model has static typing, is schema on write, whereas document model is schema on read and dynamic typing. Changing schema for document model is relatively easy compared to relational model. And second of all, it's about different relations. If your data is relatively interconnected, then relational model is a better choice because joining is easier there. And document model is good for one-to-many relations. If you want your application code to be simpler, if you want to leverage the data locality, then document model is your best choice. Now we can talk about query languages. So there are two types of query language. You have imperative one. You also have declarative one. So think about it when you have things like Python as an imperative language for data processing, whereas declarative language are like SQL. So what's the main difference? Imperative language describes how to process data, whereas declarative language only defines what data you want. Declarative language like SQL, the implementation details is hidden upon the query optimizer. Whereas for imperative language, you need to define how you want to get data. So you need to handle the implementation yourself. Because declarative language, you only need to define what you want. The query engine handles the implementation detail itself. It is also good for parallelization. But we also have a third type of language, which is MapReduce. MapReduce is not imperative nor is declarative. So it separates the query stage into two stages. One is map, one is reduce. So with map, you basically with map process, you convert your data into key values. And with reduce process, you aggregate the key. You can aggregate by key and do any aggregation you want. So MapReduce is a relatively low-level language for data processing. Some query engine under SQL is actually use MapReduce to get the data that SQL query demands. Let's talk about graph-like data models. There are two kinds of graph data models. First is a property graph model. A good example is Neo4j. Second, we have the triple store data model. An example here is GraphDB. So what's the difference here? Property graph model stores vertex, which is a node, and edge differently. So basically, each of them are stored separately like a relational database, where triple store doesn't differentiate edge and vertex. How does triple store represent edge versus node? Well, the difference is that the object is another vertex. Then this record is an edge. When the object is a string or integer, it can be a property. So that represents a node property. So, and the next question is when to use what? Property graph is good for traversal and graph update. So if you want to use your database for frequent graph update and also low latency traversal, then property graph is your best choice. But if you want a good representation of your data, then triple store is your best choice. So that's it for chapter 2. In chapter 2, we talk about three kind of data models, the relation model and the two non-SQL data models. One is a document model, the other is a graph model. We talk about the difference between relational model and document model in terms of their different schema patterns and the data locality. In addition, we talk about the two different kind of query languages. One is an imperative language, which describe how to query. And we also talk about the declarative language, which describe only what to query. Adding a little bit details about MapReduce, which is a low-level query language that is neither imperative nor declarative. Lastly, we talk about two different graph models. One is triple store, the other is property graph. So chapter 2 gave us an overall high-level picture of what is data model and query language. We'll dive into more chapters to understand more. Thank you for watching.